Today we are going to learn about Naïve Bayes classification algorithm and see its practical application using Python. Naïve Bayes is a simple yet powerful machine learning algorithm that work well for classification tasks, especially with text or categorical data. It uses Bayes' theorem as assumes that features are conditionally independent. Let's jump into the demonstration. We have Naïve Bayes classifications. Firstly, introduction. We will go through the following steps: introduction to Naïve Bayes, setting up the Google Colab environment, data processing, training a Naïve Bayes classifier, model evolution, and conclusion. Introduction to Naïve Bayes. Naïve Bayes is a probabilistic machine learning algorithm based on Bayes' theorem. It is practically well suited for classification tasks and assume conditional independence between features, meaning the value of one feature is independent on the value of another given the class level. Despite the simplifying assumption, it performs remarkably well in many real world scenarios, especially in text classification, spam filtering, and sentiments analysis. Bayes' theorem is expressed as P bracket C x equals to P C x equals to P x slash C into P bracket C upon P bracket x, where P C x, P C slash x, P C x posterior probability of class CCC given data XXX, P bracket XC, P X slash C, P bracket XC likelihood of data XXX given class CCC, P bracket C, P bracket C, P bracket C prior probability of class CCC, PX into PX evidence or marginal probability of data XXX. Naïve Bayes uses the theorem to predict the most probable class for a given set of features. Next, we will discuss about data processing. Data processing ensures that the data set is clean, consistent, and ready for training. Key steps includes handling missing values, that is, replace or remove missing data points. Second, encoding categorical variables, means converting the categories into numerical form using techniques like one hot encoding or level encoding. Third, we have feature scaling, standardize features if necessary, particularly for continuous variables. Fourth, splitting data, divide the dataset into training and testing subsets to evaluate the model's performance. Third point, we will discuss about training a Naïve Bayes classifier. We will now train a Naïve Bayes model using the Gaussian Naïve Bayes, since our features are continuous and assumed to follow a Gaussian distribution. Third, model evolution. We will discuss about model evolution. Evaluate the classifier performance using metrics like accuracy, the proportion of correctly classified samples among the total samples. It is a straightforward measure of overall performance but may not be reliable when classes are imbalanced, and it can be biased toward the majority classes. Next, we will talk about confusion metrics, a table showing the counts of true positive TP, that is denoted by TP, true negative, that is denoted by TN, false negative, that is denoted by FP, and false negative FN. It provides a granular view of the types of errors made by the classifier and highlights whether certain classes are misclassified more often than others. Next, precision, recall, and F1 score. Precision, the ratio of correctly predicted positive instance to the total predicted positive instance. High precision indicates low false positive rates, making it crucial in scenario where false positives are costly. Example, spam detection. Now, recall, the ratio of correctly predicted positive instance to all actual positive instance. High recall ensures that most of the true positive are captured, which is vital in cases like medical diagnosis. F1 score, the harmonic means of precision and recall, balancing both metrics. It is particularly valuable when there is a trade Let's look at the code now. Import necessary libraries, sample datasets. Now steps. Step 1, convert text data to numerical data using count vectorizer. Step 2, split data into training and testing sets. Step 3, train the Naïve Bayes classifier. Step 4, make the prediction. And step 5, evaluate the models. And in the last step we will test with a new emails. Now let's run our code. Here you can see the accuracy, classification reports, and new email. Claim your free coupon now. Prediction, not spam. From the result, we can see the model accuracy and its ability to correctly classify the different classes of the confusion matrix shows where the model misclassified, and the classification report provides detailed metrics for each class. To summarize, Naïve Bayes is a simple yet effective classification algorithm. It works particularly well when features and independent or in applications like text classification, while it may not always handle highly complex dataset. Its simplicity and speed make it a stronger baseline model. I hope this demonstration helped you to understand how to implement and evaluate Naïve Bayes in Python. Thank you.